Okay, let us go ahead and get ourselves started again. Let's see if we can actually make some sense out of that whole notion of really using the math floors and the comments to go through and do a little bit of filtering based on that. I'm going to try something just a little bit different, and it'll just sort of give us a sense of whether we can or not. I'm going to take that get element parameter value function and just kind of plug in a very slightly different string. So we want to see if we can just basically get out the comment, is really what we're interested in. So, because if we can get out the comment, then we could go ahead and use that as a filtering criteria. Okay, so let's try this. Doesn't seem like it likes that. Parameter comment was not found. Looks like comments may be the parameter. That's never a good thing. Let's see, I try bringing that back up again. Again, 15.2. Just check this out. String. See if I can get that comments to plug in there. Cross your fingers. Once again, interesting. Wonder if comments is a little bit strange in terms of what it's doing. Behavior changes. I'm a little worried about what that is. I might need to just do some restarting in terms of like, but, well, let me pause on that one because I want to go ahead and get started on the next piece of it. So give me a pause. I owe you on the comment in terms of being able to filter on that, but I am pretty certain if we can get it to stop crashing, that's actually going to work too. Okay, let us go ahead and continue because I just want to take you to a slightly different example that I think is kind of interesting because this little twisting tower has been okay, but there's more to life than just our little twisting tower, and I want to actually kind of just sort of take you towards a building which is kind of a very interesting shape, very noteworthy right now, and it's the Freedom Tower, which is just about open. I guess it's open now. Take a look at that, which has kind of an unusual and interesting shape, but let's see if we can go ahead and model something like this. The Freedom Tower actually has kind of an interesting shape to it. You'll see it has a number of different sections to it. It actually has a big base at the bottom that's actually 200 by 200 by 200. It's actually a big cube at the bottom, and on top of that cube, you actually have a tower that rises to a height of 1,863 or 36, one or the other, feet. It's actually the same height as the original kind of World Trade Center towers. Okay, but it does it in an unusual way. As opposed to going through and just rising straight up, it tapers. It kind of has this little 45-degree twist. The corners get knocked off as you go heading up there, and it kind of creates sort of an interesting shape that we can go ahead and model. And I wanted to kind of demonstrate to you a little bit about how we can model that and actually start analyzing something like that using all this programming and linking and looping methodology that we have available in Dynamo. So let's take a look at that tower. And first we're going to go through and just create something that looks like the tower so that we can go through and do that. In terms of modeling something like that, what I tend to do when I'm modeling this tower is actually create profiles which represent the shape at any individual level. So at the base, as well as at the top of what I'll call the podium level, I have a very basic shape. It's really just a big square. It's like 200 by 200. It's just a big old square. As I move up the tower to the top there, I have another shape for the very tip top of the tower, okay, that is really more like an octagon. Okay, it's an octagon with very truncated edges. You'll take a look at that. But really, everywhere from the top of the podium up to the top of the tower is really just a smooth transition between those different shapes. You really can get by with just one shape, the same shape here, and the second shape up there, and that'll actually take care of the whole tower for modeling it. And just to give you a sense of what that looks like, let me kind of open up some of that stuff in Revit and give you just kind of an idea of what it could look like. So in looking at this, if you go to session 15 examples, there's a couple of different examples of profiles. Okay, you'll actually, if you want to take a look under building profile 2, spelled funny, that's actually the profile that we've been using for the twisting tower. You'll see it's the funny little it's that rounded triangular shape, okay, with a little thing that allows it to do the rotation and kind of just change its shape based on the amount of radius and the amount of rotation. And you can play around with that profile. That's really just a 2D series of lines. And if you change that, and you say that the rotation or the radius is going to be 80 and apply that, the profile adapts. It's really just, this is just a shape, but it's a very good way of building shapes is if you can build things out of profiles that are parametrically controlled, that gives you kind of a layer of insulation. They sort of hold together. If the profile shapes or reshapes nicely, then the tower will shape nicely too. So it just encapsulates things a little bit. Profiles are a good way to do that. So what I wanted to do was actually go through and create a profile for the base of the building. Okay, and the base of the building is actually pretty straightforward. This is something that'll look very similar to all the work we've done with any of the different sort of smart parametric objects where I set up some reference planes, I set up dimensions, and then really I'm just really setting up reference lines or model lines, to go through and match that shape. So the idea here is that for the space shape, let me just take it out right now. We have these reference lines. They're just waiting to be flexed. So if I go through and flex those things, it'll make it, 9 feet by 9 feet. Okay. The reference lines have flexed. They're looking all good in terms of what's going on. Let me push that out. So now it's time to basically just put some lines in here. So I put model lines in. And using that same technique that we learned in 110 or 120A, I can lock that to those different lines, and then this profile will change. It'll go through and flex itself as those lines change. Inside. Okay, so the base profile is very straightforward. That, no problem. You got that. That's really easy. It looks like every tabletop, all the different objects we've created so far. The upper part of the tower is a little bit more complicated, but not too awfully. Let's take a look at it. At some level, it is very similar to the base of the tower. The outer edges are really just the same as the base. In fact, they match up with the base in the tower. Okay. What we did was we added just a few more lines on the inside to be what I'll call the flat sides, or it's kind of this interface. And this is the part that tapers as you go moving up the tower. Really, at the top of the tower, there are these little short sides on the front and back and on the left, right centers that really determine how much it goes through and tapers up. So the idea is when you get to the top of the tower, it looks something like this. It's it's very skinny at the top and bottom. Okay. And then it just kind of smoothly tapers on down where the flat faces actually continue straight on down. These big triangular faces on the corners, they're the ones that kind of taper all the way down, from the top to the bottom. But this profile gives you an awful lot of flexibility for controlling this thing because you can go through and set this profile at the top of the building, and then we can change the amount of what I'll call the flat side 1 and the flat side 2. And as we change that, you really change the shape of the entire face of the tower because it's really just changing the shape of the profile. So for making that profile, it wasn't all that hard. the whole notion of setting up these different reference planes and setting up the equations and a parameter on that, that I think you guys understand how to do. That's not so bad. Where it got more interesting was, let me show you this. I'll take those all out. Okay, these are all just the raw reference planes, just waiting to go ahead and have that model lines added to it. So where that gets added in is we can take the model lines. And again, I'm going to use the align tool to do something very similar. But I'm going to get a little kind of creative here. What I'd really like to do is actually just knock off all those corners, draw 45-degree lines at those corners. So what I can do there is actually create a model line, and let's go from the intersection to the intersection right there. The intersection to the intersection. Okay. With those, I can now do a little trimming to kind of just complete the shape because I just want it to be a loop. So I'll do some trimming of this side to that. Okay, so with any luck now, I have something that's going to flex nicely for me. Let's just go ahead and test it out. Let's make it like 2 feet by 2 feet. Okay, looks like it did pretty good. Okay, so I have these 3 different profiles. I'm going to get them all together in terms of like trying to create this shape. So I have the lowest profile, which is a square, the middle profile, which is still a square, and then like this one, which is going to be the top. Yes?
For creating the profile, why didn't you just draw those lines that you have instead of having the one at the outer edges and then trim it? Is there a difference if you do that?
There is a little bit in terms of just the geometry flexing, and it's this funny thing about Revit in that it really loves it if there are reference planes and you push reference planes around and then you lock things to the reference planes. It's just a little bit stronger in terms of, you know, not breaking down around the edges. So it's a level of indirection, but it just makes for stronger elements. No. And it's a weird answer, but it kind of comes down to that. It's less likely to break this way. But, you know, there are times you'll see me shortcutting and just dimensioning right to the lines. Okay, so what you got to do is then we're going to pull all these things together. And how I pulled all these things together, if you go ahead and open up a family, you'll find out there in that session 15 folder. Oops, it's in the conceptual masses. You'll find this thing, parametric tower shape, Freedom Tower. And you actually see this thing. Let me kind of take it out of there and just kind of show you how it looks before I do it. So it starts with just those 3 different profiles. I have a profile here, a profile here, a profile there. And what I actually did to go through and create this is set up a couple levels, a level which represents the top of the podium, and a level 3 which represents the top of the tower, and dimensions driving those. And then what we can do is then place those profiles on those different levels. I'm going to show you what I have in mind. So over here, this is that profile placed at level 1. Okay, just kind of square on there. On level 2, again, I place this profile. At level 3, I'm placing this profile. Okay, but adding those three profiles together on those three different levels gives you something that looks like this. If I move them up and down now, for example, if I go ahead and change the tower height to be like 1200, that'll move that down. If I go through and change some information about the profile, for example, these flat sides or the kind of base side here, it'll go through and reshape that. So what I did was I took those three different shapes, and what I'm going to do is I'm going to grab that shape and this shape and say create a form out of that. I'm going to take that shape and I can grab just the profile. That'll probably do it. Okay, now I have the overall shape. Now, in terms of making this overall shape, I wanted the ability to go through and control these different profiles. So I have these different profiles at the bottom, the profile on the top. I wanted to be able to control them, okay, using parameters that were controlling the overall shape. So what you can do is actually put a little tunneling between the parameters to allow you to go through and control things at the outer level. So what we can do there is, for example, if you choose that top profile, you'll see it has some values here, but these values are actually equal to something else. What we've actually done is related those different values to values which are available for the overall shape. So I'm going to put in input parameters for the overall shape that in turn are going to drive the profile. Okay, so here's how that works. For flat side 1 or flat side 2, it's actually going to something called tower top flat side bounded, flat side 1 bounded. This is going to flat side 1 bounded. The base is just going to tower base 1 and tower base 2. So here's how it basically works. Over here, we have some different parameters set up. And for the most part, I want to leave things pretty open-ended. So if I put tower base 1 or tower base 2 in here, it'll channel down and actually control the shape of the profile. Okay, make that open or close as we need to. For the flat sides, that's actually going to control the shape at the top. Okay, these little tiny lengths over here. What I wanted to make sure, though, is that the size of the flat side, okay, was never going to be greater than the base. Okay, so I actually went through and changed it just a little bit. I put the top side, or the flat side 1 and flat side 2 in there as values that you can put in there. Okay, then I created another thing called bounded, and let me show you what that's all about. Every once in a while, you set up if conditions that bound and restrict values just to allow that people may put in values which don't make sense. Okay, and it's ultimately going to break your geometry. So what I'm saying here is that if you go through and put in a flat side that's a small number like 10, if it's less than the base, go ahead and just use that value. But if it got greater than the base, don't get any bigger than the base. So I say basically go to the base size, and just to allow myself a little margin of error, I'm subtracting 1 foot from it. Okay, so there's always some very small difference at the side. It can never be bigger or fatter at the top than it is at the bottom. Okay, so setting up these two different values, do that. But you know, there's a lot of logic behind all this, but let's go ahead and try just flexing it and sort of see if you get a sense of what the tower is like. So given this tower, and you could either kind of do it by opening it in the Revit project, or you can do it just by playing with it inside the example there. Let me go to Freedom Tower 15.3. Here it is placed. But let's just try flexing it around a little bit. So you got this guy, it's got some different dimensions over here. So if we go through and raise the height to like 1,500 feet, you'll see the tower increases. In this case, it's not increasing. I need to add some more mass floors to it to kind of give some more of those. If I go through and change the tower, what I'll call the top, the flat size. Okay, here it's 10, so it's very, very skinny at the top. This is actually very much like it is in the true tower today. But if you went through and put a different number in there, you get these other shapes which are really more kind of strictly octagonal. What's going to happen over here is, if I put in here a big number like 195, it's still going to be okay, although it's just about squarish there, like the original towers. I didn't want to allow that you could put in a bigger number, like 250 there. So that's where we have the cap. This tower top bounded, okay, is just the base minus 1. So if you put in something bigger than the top, it's going to stop it and not let it get any bigger. So let's talk about really what our problem is, and we'll go ahead and tackle this next time in terms of doing this. We basically have a tower, and we would like to go through and kind of flex it and kind of play with it a little bit in terms of what's going on. So here's what we're going to do. We're going to try changing different variations on that tower flat in terms of being very, very skinny and pointing, being very, very wide. Okay, but as we're doing that, we want to think about the whole notion of the total amount of floor area in here, because let's kind of show you how it works. If you go through, and I'll make it back to like 1,300, it'll be a little bit easier. See? Okay. When the tower is very skinny and pointy at the top, our total floor area is around, what, 3,441 square feet. If that tower is very fat at the top, you'll see it's 3,959. So we have an interesting problem here. It's going to require us doing a little bit of playing around. I'd love to actually try varying two different things. I'd love to go ahead and try varying the amount of thickness at the top there, okay, but at the same time, because as I change the thickness, the total amount of square footage in the building is going to change. I'd like to, for any change in the thickness, also have the tower adjust its height so that it's always keeping the same amount of like square footage in the building. So this almost gets to Hong what you were asking about. We're going to set something up where it's going to do two things. It's going to start by going through and changing the value for the slopiness, for amount of pointiness, but then within that, we're going to have to do a little sub loop that's going to go through and adjust the height. And for that sub loop, we're going to do something a little bit special as opposed to just changing between a range of values. That will do for using the for each loop. That's what we'll do for the amount of pointiness. For this issue of changing the height just right, we don't just want to range through a whole bunch of values. We want to say, go ahead and target. Can you find a specific height at which it's going to cross the threshold for the number of square feet we want? Okay, and that's what we'll do next time. We'll show you how to basically create a targeted loop as opposed to just a for each loop that's really zooming in and trying to get a specific desirable value. Okay, so let us break there. That's where we'll pick it up next time. A little like a multi-loop action, but it's by the time you do that, the thing is dancing and changing and twisting all at the same time. It really does an awful lot of computation in the background for you. So it's very, very useful. Okay, let us break for today.